The break. Hi everyone, welcome back. My laptop is rapidly dying, so I'm going to make this short. We've got 3 great papers. Hopefully we'll be able to record them all. Take it away.
Thanks. I'll try to be brief and quick then. Hello, my name is Sergio Fernandez. I'm a PhD student here in the University of Alberta in the CS department. And I'll be here presenting in behalf of the rest of my team the paper we wrote on deep learning for classification of speech accents in video games. So just want to go a little bit over what the goals for the overall project is. So we're working in part with other faculties on this bigger project, and the goal of it is to examine how accents of English are used in video games, thus how they perpetuate or not dominant linguistic attitudes. And overall, the project is trying to do some content analysis of games, but also create a game clip database and metadata that will hopefully encourage more of this kind of studies. From our perspective, from CS, we were interested in how to facilitate some of the process, some of the elements of this process that they were going through. In particular, how to classify, if we could train a machine to classify the accents in the games so that we don't have people going through the games, listening to it, and annotating them by hand. For this, we use data from the Dragon Age Origins series to train a machine to differentiate between accents. The main reason why we started using the Dragon Age games is because for this particular study, the team felt that the games were able to have very distinct and differentiated accents, and they use accents in very particular ways in the game, so it facilitated the study for it. And we hope that doing this type of analysis informs future game design by allowing great diversity and inclusiveness and less stereotyped uses of accents in speech. And in fact, there's some already, the team has some results on this type of analysis that will be being published next year. So this whole process started with Dr. Ensley's pilot study, where she started to analyze how accents were being used in games, and in particular like the naturalization perpetuation of the Pax Americana. In other words, how we've seen a lot of entertainment accents being used, American accents being used for the good guys, while the bad guys have other accents, being British, Russian, Italians, whatever, other than the American accents. So Dr. Ensley started to notice this and wanted to study it more and see what the how would games were using this element to otherize the enemies of the players. So going back from a CS perspective, which is my background, we wanted to help, like I said, help them in labeling the data. Instead of having someone just going through hours and hours of audio, if we could feed that into a machine and the machine tells us where the accents were being used, it would facilitate this kind of study, hopefully. We also wanted to use existing technologies, existing architectures, to see how easy it would be to set something like this so that other studios could hopefully begin doing more like a self-analysis of their own games. For our approach, we decided to use a pre-trained network, in our case AlexNet, to differentiate between accents. And this was in part because we were also working on other types of data sets, and we were already working on some classification based on images using AlexNet. So we wanted to see how far we could, and we were getting good results for it, so we wanted to see how far we could use this same approach for speech accents. And since AlexNet is a visual classification network, we had to use a visual representation of sound. And the way we approach this is by using spectrograms. But we weren't just using the spectrum as this, we were creating this little, what we call a 2x2 spectrum, which is composed of 4 different spectrums, where we play a little bit with the scalability of frequency, both linear scales and log scales of frequency, and the same for amplitude. And the reason for this approach has something to do with the fact, like I said, we're working with bird data originally, and this approach seemed to be working with that data set. So we wanted to see how much of it we could translate into the speech accents. And here's a little bit like how the spectrum for this particular clip sounds like.
You're looking for a place to sleep? There's a vent behind your vasts. You don't mind if you use it.
So the reason why I put this out there is I'll come back to it a little bit. Try to start thinking a little bit of how it sounds, what accents it might be using. So I'll play it once again.
You're looking for a place to sleep? There's a vent behind your vasts. You don't mind if you use it.
So our goal was to gradually increase the accuracy of the network for classifying different accents, and hopefully we started using 2 different accents and hopefully start adding more complexity into it so that we could classify a breadth of different accents. So last year, during this same workshop, we presented our first early results. So for this setup, we started using, since we didn't have enough data from Dragon Age at the time, we decided to use another data set to train the network. This, in particular, a speech accent archive, which had accents from different, English accents from different parts of the world where you have speakers enunciating or pronouncing a particular phrase all the ways the same. So we thought it might be a good place to train the network. We used data from it to divide it into train and test sets. Because the files were longer than 20 seconds and created spectrograms, a spectrogram of 20 seconds down into a 227 by 227 image, we thought we were losing a low resolution. We decided to instead divide each of the files into 3-second segments. And we created spectrograms for each of these segments. And again, we resized them to 227 by 227 pixels, since this is the input for AlexNet. And the results were, I'd say, fine. They weren't great. It was around 75% test accuracy when the majority class, a random classifier would be about 50%. Again, not great, but there might be something else. The problem, or the bad, really, really bad news was when we applied this network then to the Dragon Age origin files. For this, we had a total of 17 files. And we didn't train the network on these files. We just, the train network that we already had, we applied it to these files to see how they were classified. We processed them the same way we did with the speech archive data. And our accuracy was bad. That's to put it kindly. 52.7% accuracy when our majority class was 51.2%. So we started looking at why were we getting why were we getting bad results? Why were it so bad? So one of them was, well, talking with different linguists in the field, collaborators here, they were talking about how we had this suspicion that, well, when you're listening for movies or in games, actors tend to be really conscious of how they enunciate. They're more careful how when they speak, it's more clear. So we were wondering if maybe that could be some of the confusion that the network was having moving from one data set to the other. Talking with some of other collaborators that we had from the linguistics department, they were like, that could be a possibility. It might be worth exploring. So for this papers, for the current papers work, because of the time difference, by the time we started working on this paper, we had enough recordings from Dragon Age Origins that we felt like we could now start training the network directly on that data set and see if there was any difference. Like for this one, we had a total of 295 audio files recorded. They were evenly split, 147 labeled as American, 148 labeled as British by our team. And again, same setup as our previous experiments, divided into 3-second segments, trained the spectrograms for them. And our test accuracy actually went up. It went up to 63.25%. Still not as great as the original results we're getting when we're just doing the classification based on the archive data set, but better than we were getting for the Dragon Age Origins data, which is ultimately what we wanted to do, right? We wanted to be able to classify the files from our data accurately. But still, results weren't good, so we started looking at why the low accuracy. So we started, at the beginning we had noticed that the team started to notice that there was some inconsistency in some of the accents being used across the same file. So one character might be sounding British 1 second, then the next one they might sound American, and this might be because you have an American actor trying to do a British accent, and they just drop at some point the accent, or the other way around. You have a British accent trying to imitate an American accent, and they cannot keep it consistent throughout. Also, we started thinking about, and so the fact that we had the 3-second segments, it could be that one of those 3 seconds, that was exactly where the accent was dropped, and then everything else was consistent, so that second would be causing problems for it. Also, we started thinking, well, the 3-second segments was a little bit a toss of a coin. It felt like a good number, but we hadn't really done a lot of experiments on it, so maybe having a lower duration could be good, especially since some of our files are along 50% of the audio files were actually themselves lower than 3 seconds in length. So maybe that could also have been doing kind of problem. So we started looking at how could we mitigate, or how could we handle with this kind of processing. And a little bit of, to show a little bit of analysis that we started doing for one of the files. This is a soundbite that I played before. So again.
You're looking for a place to sleep? There's a vent behind Gavasts. You don't mind if you use it.
So for this one in particular, the team started identifying, the first time we heard it, everyone's like, oh, this is a British, or if not British, at least not American. And we started looking at it and it's like, well, why do we say it's not American? And the team was like, well, it's because of the Basque. Like the pronunciation of everything else changes at certain points. But in this particular one, Basque was very notorious. So we wanted to see that the network visualize a little bit how the network was classifying each of the different segments for that file. And here I have the graph where is everything else. The blue one is the network saying it's British, and the red one is saying how American it is. And we did notice that the moments we were saying that sounds British or that sounds not American, the network was actually classifying correctly. Some of the other areas where the network was saying it was American, we went through it and we were like, yeah, that does, like, you could be, if you just look at that segment on its own, there's nothing to say that it's one or the other. So we started looking at this element, at these fields, and we saw, well, the network is getting most of the file as British. Why don't we just classify it as British, the whole file? And that's kind of what we did in our next experiment. Instead of like classifying each of the segments, we started looking at all the segments. What information would you get from all the segments for a particular file? So if, for example, we had 5 segments if we had 5 segments for one file and 3 of them were being classified as British, we would now say, well, the whole file is British. The network is saying that there's a big inclination that the accent being there is British. And this, again, helped accuracy a little bit go up. We went all up to 68%, so almost 5% more. Again, still not perfect, but it was giving us more, at least it was showing that somehow the intuitions we were having about what the network was doing were being related to the scores. And finally, like I said, we didn't know how the 3-second segments were actually helping or being a detriment. So we tried out 1-second segments, but this time with the profile setup. So same setup as the profile. So we're looking at the majority vote for each of the segments in one file, and and we're classifying, but instead of 3 seconds, it was 1 second. And the network accuracy started to go up to say 1%, closer to what we had with the archives. Still, again, not great, but better than we had last year, but still a lot of place to go with this approach. So what for future work? So what are we looking at? So one thing we have to struggle with a little bit here is authenticity of access in video games and how to classify hybrid actions. So it's not only whether or not the actor has their accent consistent throughout the character's portrayal, but also there might be weird accents that become present only in the game. Here we have a photo of Lady Basilia, which was an interesting case. So no one in our team was able to actually identify what her accent was. So they started to, since no one could agree on the accent, members of our team decided to go online to see if there was a consensus. Of course, this being the internet, there was no consensus. But it was interesting to see, usually you have, in Dragon Age Origins, accents are used a lot by race. And there's an agreement in the community of what races use which accents. But with her, no one could agree on what the accent was. So it was very particular. And it could be that actually her accent doesn't align to any of our own accents, right? It could be that during recording, the actor tries do a weird accent. The director is like, oh, I like that, so they keep it. But then there's no analogous, or they're trying a combination of German and British, and so now it's how do we disentangle that? So that's another aspect that we had considered at the beginning of the project that we have to take now, that we are now taking into account, and we still don't know what the answer is and how to handle it. We're still investigating it. And so even with all those problems with the actual accents, we also want to improve the performance of the network. It might be good that we know how to handle these accents, but the question is how do we still improve the tool to actually be reliable? One of the ideas is, one of the problems that we have, as probably in the story here, is we might not have enough data for it. Maybe the 100, the 290, almost 300 files that we have, which with the 3 segments, we in the thousands of samples for the network to train on, it might still not be enough. So could we use some of the other data sets that we've been working on? For example, like I mentioned, we had been working on some bird data sets beforehand, and for that one we have a lot of data, more data than we know really what to do with it. Could we use this data set to train the network on getting spectrogram specific features, and then train the rest of the features on the accents? Also, looking at different network architectures other than AlexNet to see if we improve. For the whole train on the birds and then seeing spectrogram features and doing then using that same network on accents, we have some early results that we've been doing over the summer after we submitted the paper. There seems to be some improvement in the results, but again, they're just preliminary and not promising, but not yet ready to be publishable at all. So to summarize, so the goal of the project is to examine how accents of English are used in video games, how they reinforce or not stereotypes that we have about good and evil and different races and otherizing individuals in games. Our approach was to train AlexNet to differentiate accents. For this particular paper, we used Dragon Age Origins R recordings, and we tried different approaches, experiments to see how the networks will respond to it. We did get better results than we had last year, but there's still a lot of room to grow. And also, we've seen that how we handle data has a big impact in our results. And these are just experiments that we've been running on our own, but we still feel like there's a lot of validation that we have to do for our approach to be sorry for the redundancy, valid and used across games. We haven't even tested how, if we do get a good network trained on Dragon Age files, how that network will do with any other type of games. It might be that we have the same case that we had with the speech accent database, where we trained on that, we had okay results, but then terrible results when we moved to another dataset completely. So those are still things up to work. Anyway, that's all I had for you today, so thank you for your time, and you have questions? Yes.
Thanks for the talk. I'm curious if you're aware if there's any sort of related work either in industry or academia about using accent recognition to improve the accuracy of speech recognition. So like if you can identify that the speaker has, say, an Indian accent, then that can go into how you're recognizing the speech and improve the quality. Do you come across anything like that?
I have personally haven't, but we have been thinking of also how to kind of use this, how this tool could be used maybe to help casting directors in some ways. We just kind of like floating around, you don't even know how it would be, how to do it in a good way without having it be prejudiced. But yeah, I don't know. I haven't read anything about it. You can.
Can you talk about why you're using spectrograms to represent the audio?
It's a little bit of like I said, we've been working with different data sets in the project. We started with using birth data, and for that one, there's some spectrograms that do have some very particular kind of features. So it was just a matter of we already have, and we were getting really good results. So it was a matter of we're using this technology. We have this other data set. How translatable is what we've been doing with one applied to the other? That has a little bit more to do with my particular interest in applying, like finding methods to work around audio-based data sets. So it was like some matter of let's see if we can the same process apply work on two data sets. That's mostly where that comes from.
And then I had a follow-up.
Yeah.
So then, do you have a sense of, let me ask this question first. Do you have a sense of why you saw the improvement when you went to 1 second versus 3 seconds?
I haven't gone too much detail. My part of the intuition is that some of the, let me just try to rephrase it. I think it has to do with the scalability. So with the part of it, I think has to do with the fact that, like I said, we had some recordings that were less than 3 seconds. So we weren't just disregarding it. So we were taking those like 2 second, 2.5 second segments, and we're doing a spectrum also. But then we were like the amplification to the 227 might have changed a little bit how the features look. Yeah, the resolution. So I think part of because if you notice, it wasn't a huge increment, it was a small increment. So my intuition is that maybe it helped with those particular files, but it didn't like overall help the bigger picture of things. So, yeah.
So in the case of the hybrid accents that you're talking about, is the problem that you're running into there that each of these segments is, so if you have a clip that's however many segments long, is the problem that like each segment is getting classified differently, or is the problem that none of the segments are being classified reliably?
For the ones that we looked at, it was more of some of the segments weren't being classified correctly in the file, but the majority were. So that's where we went to. Okay, let's now see how the results change when we look at when we apply the level to the whole file based on the majority of the segments.
Okay.
So that was what we, yeah.
So then in the hybrid cases, it's like the problem is that it's there's 50% British, 50% American, and you can't really.
Yeah, and especially if, for example, with something like Dragon Age, where for example the elves tend to have more British accents, right? We could go in and be like, oh, that's supposed to be British and everything, but the problem would become, like, for example, let's say in another game or another culture base, the director would say like, oh, we want 50% American, 50% British. And if we do come across that setup, we still don't know exactly how we're gonna go about with it. But yeah, in the case where it's like, it seems like there's close intention, then yeah.
Sorry, one more. In that case, it could be interesting to instead of outputting like a direct classification, outputting like the I guess percentages. So like, oh, we don't know exactly what this is, but it's kind of American, kind of British, kind of this other thing. And even if that doesn't give clear categories, it should give some kind of feedback that might be useful.
Yeah, no, yeah, absolutely. That's something else. Well, thank you very much for your time.
For a adapter, what's the kind of adapter you need?
You have Type C to HDMI.
Does anybody have a Type C to HDMI adapter?
Yes.
Okay, cool.
Let's make sure I brought it.
Given a large enough section of computer science, so every adapter
Thank you.
Also, we have power for the stream. No danger of it crashing on us now.
The power was in you all along, in the ball.
Get a longer table or just move the table?
No, the table is all the way up there.
Oh, I see. Right. That's working.
Yeah.
Are the live stream? So is the live stream also being archived?
Yes.
Okay, solid.
Yeah. If you want, you could rewatch my talk from this morning.
And who wouldn't want to?
Me.
HDMI is dangling. That's HDMI. Yeah.
This one.
No, that looks too big. It looks like it's one on the side. Yeah.
There's 4 holes. I hope one of them fits.
That's okay. It's okay. Just relax. It's right here. There we go.
Always the hardest part.
That's already up
Would
there.
be a conference without tech issues.
Unlikely. Okay.
I thought they were supposed to have a mini display coordinator.
Let's try VGA instead. Hold on. Here it is.
Oh, great.
You need sound?
Yeah.
Okay, so plug this in for your microphone.
And here we go. Hey everyone, I'm Zio Lin. On behalf of the Entertainment Intelligence Lab, at Georgia Institute of Technology, and also my co-authors, Cal Xiao and Professor Mark Randall, who is my advisor. I would like to present GenerationMania, learning to semantically choreograph. So let's talk about rhythm action game first. Well, I won't be reading that definition anymore because we had a mention a while before. But I do want to talk about a rough classification of rhythm action game. Since you have played a lot of rhythm action games like Dance Dance Revolution, or probably like Guitar Hero, or even newer things like Beat Saber. If you have already played it, it's a pure rhythm action game. I roughly classify this game into two types, or to say two dimensions. The first one is about whether it's a performing game, whether the overall goal of the game is recreating the music rather than doing something to accompany the music. The second dimension I'm talking about is timing-based, or to say whether the player's performance is being judged on how accurate their action is, rather than how good they are doing their actions. By using these two dimensions, these two things, we were able to, put a lot of rhythm action games into a spectrum. Today, we are going to focus on one type of rhythm action games, which is Beatmania. As you can see, it's on the rightmost top side. It's a performing rhythm action games and also a timing-based one. Remember that we'll be talking about how important that is later. So let's take a look at what Beatmania is. So it's a Japanese game. Probably the Western counterpart that you all know is Guitar Hero. If you don't know both of them, that's fine. You can see that when you are playing the game, you will see some on-screen hints as falling objects. And by using these controls out there, a scratch and 7 buttons out there, you try to recreate the music as DJ. Just like a DJ. Pressing these buttons and scratching that scratch-like control plays audio samples, and your final goal is to arrange them perfectly to form the original music. Let's take a look at an example gameplay here. I have the video here. Or not. Give me 1 second. It's better with music, so I decided to. So as you can see, on the left button side, there's a player using both of their hands to press the controls out there, and you can see the music is being combined. By the player pressing the buttons and at the corresponding correct times. Let's cut it off here, and so as you can see, it's a pretty interesting game. So there are many people, including homebrew communities, probably just like Super Mario makers. Players actually try to create stages. There are a bunch of people actually try to create rhythm action games stages. However, as you can see, the stage can be pretty complex. Things can be pretty hard, and this usually requires professional knowledge. So we asked ourselves a question: why not just procedural genreism? Let's first define what we want to do here. We call what we are doing learning to semantically choreograph. This is the problem of developing interesting rhythm action game stages that maps to the underlying music strictly. This is an interesting restrictive procedural content generation problem. Let me go in depth into why we are saying that it's restrictive. So as you all know, music can be treated as sequence of audio events. In this case, in the community, we usually call them musical notes. It's not the case that every single note is not every single node is mapped to a game object, clearly because or you will get something that is unplayable, that is too hard for everyone. However, every node is necessary out there to create music. You can't just have half of the music, to have the full music, right? So there yields a problem here. We need to look into playable nodes, which we define as things that appears visually on the chart as a hint to the player, versus something we call non-playable node, which is automatically played as part of the background music. On the right-hand side, you can see an example table listing like a hypothetical music event sequence. You can see that some of the notes, or to say, let's say the first note, which is a drum, which is placed onto the stage. However, it's the same drum note, but at a different time. It is no longer mapped to the stage. It becomes something that is played in the background. So we separate the learning to semantically choreograph the problem into two subparts. First, we need to classify samples into playables and non-playables to know which objects we need to put onto the stage. Then we look into which stage object we should make this audio event map to. We especially look into the first problem because this is the restrictive part, restrictive PCG part of this problem. Let's first talk about how people did that a while before. So we have talked about learning to semantic choreograph. You may have wondered how we coin this term. Most of them are not coined by us. It is a term that is used by this group of researchers who did a paper called Dance convolution. It is described. It is the term they use to describe automated rhythm action game stage generation. So let's talk about how people did that, the whole learning to choreograph thing before. So there's rule-based systems. It's actually pretty ancient. You should have already played a lot of games on App Store that claims that they can use an MP3 to generate some charts. It is most likely a rule-based system. It's nothing new. And some of the other works that relate, that is pretty old on this paradigm is things using genetic algorithm. It's only recently that people started to treat that as a PCG-ML problem. Especially, listing this group of researchers who did that last year, who used a neural network to generate revolution stages. Okay, so we have talked about our learning through choreograph, which has a long line of related work. But why do we need to actually look into semantics here? The problem here is that as a classical learning through choreograph paradigm, it does not require every and each game object to map to something in the underlying music. Okay, think about it for a while. You may actually have a question here. You may say, well, isn't that what rhythm action game is? Sadly, nope. Here is a classical example here. Let me show the video. Let's see where I can get the scene. I should be having a little more sound here because there's one thing that I want to catch up. Okay, let me cut it here. Did you realize that there's actually no, not every single object here is mapped to something in the underlying music. Clearly, there's nothing like, nothing like everything. It's not like a 16th note exists. Oh, do you have a question?
Sorry, this is about the video. I have no idea what the person playing the game is doing. I have no idea what inputs map to. What the fuck is going on?
Swear jar.
Sorry, I've got a quarter for it.
That's fine. That's fine. So the point here is that this game is actually a different game than Beatmania. In this game, you try to play taiko drum, following the on-screen hints. So the player is using a controller instead of an actual taiko, and when the player presses a button in his or her controller, there is a taiko drum sound playing out there. And the overall goal of this game is to just play something that follows these on-screen hints. And in this chart, in this signature chart out there, although the music is something that is pretty, let's say normal, that it's not, they don't have like a 16th note at every single, there's not a musical object at every 16th note, but in the stage, every 60th note and every 60th interval, you get a game object. It's like, this is actually a high profile stage in that game, but this doesn't map the strict relationship that we are looking into in Beatmania. Let's go back to the top first. So that looks a little complicated, but let's talk about what is happening there in fundamentals. So the point here is that in that chart from another game, there are overmapping happening. We define overmapping as a non-strict relationship, non-strict one-on-one relationship between a musical event to an on-screen hint, or to say to a game playable object. There are two cases here. The first case is that one musical event can be mapped to more than one object. The second case here is that there can be just stage objects coming from nowhere. It can map to nothing out there. This actually happens not only in these taiko drum games, this actually happens in Dance Dance Revolution. If you look at some of the charts out there. And wait, there's actually more. It's not only that we deal with overmapping that we realize the semantical part of this problem. There's actually more semantic constraints in these charts. Notes sharing similar semantic are actually usually consistently mapped to the game stage. Let's look at a quick example here. So as you can see, I actually put an example chart out there and place some color hints on which instrument they're representing to. And on the right-hand side, you can see a musical score. As you have already guessed, this little twinkle star. And these white notes corresponds to the left hand, what you are playing using your left hand on piano. The green part represents what you are playing using your right hand on the piano. And the red part is the drum beat part. Two things that I want to point out here is that first, the pitch of the musical events plays a critical role in how we manage these notes. Secondly, you can realize that in this column, things are pretty strange here. It's not in the same color, which means that different instruments can be mapped to the exact same control out there, which is something that adds complexity to this problem. We have talked about how challenging that problem is. Let's look at how we deal with that problem. Here's our overall pipeline here. We start by classifying all the audio samples for each note. Then we look at existing charts, gather a difficulty curve and a chart summary out of it. Then we use these information to generate, to to generate new chart by first selecting playable nodes in the new chart. Then we place the playable nodes to the stage. So let me walk through. Let me again walk through this pipeline here. The first thing we did is that we take a musical piece and we look at the sprite representation, or to say the event representation. So we are not yet dealing with you have a question? We are not yet dealing with raw audio input. We are just, treating music as event sequence. We classify every single every single sample here into one kind of instrument. Then we extract information, just like from the existing charts. We extract a chart, a difficulty curve, a summary. Then we use this information to generate the scene, starting from playable notes, and then on where we should be putting that actually onto the stage. So for the audio classification pipeline, we use a popular method by these people, which is that we extracted a spectrogram of audio samples and generated some audio fingerprint. Then we use a neural network to put them in different categories. So for the categories, we looked, we hand and picked them by looking into common instrument selections with some partially labeled samples from another rhythm action game audio sample data set. Then we start looking into how we're extracting information and we're applying this information to generate a chart. In the training process, we extract the chart summary and difficulty curve from human charts, of course from data set. In the generation, when we do the generation, obviously we do the inferring. We generate charts by looking at a novel musical piece and applying some existing chart information into it. Okay, let's talk about why we decide to extract these two pieces of information here. The first thing is, of course, difficulty modeling. We believe that our assumption is that charts should factor in difficulty. So by saying that we want the charts, or to say the game stage, should be factoring in difficulty, it's not clear how we define the difficulty. So we asked it a question to us: how challenging is our chart itself? There's a lot of things that is out there. It can be rhythmic patterns, it can be physical strings. Actually, going to that, for rhythmic patterns, it's like, sometimes, there's like a stairs. There's probably like two, you have to use your two fingers to press simultaneously, or it's maybe physical strings that you have to press a control 10 times a second, or it can be personal differences due to people being right-handed or left-handed. So there's a lot of things to consider here, and we realize that a single number may not be something that works for our paradigm. So we decided to look into generating a difficulty curve. We used a model called the OSU model, which is a model used and developed by the OSU community, which the original use is to generate a difficulty coefficient for laddering, for calculating how good a player is. We instead use this model to generate a difficulty curve for each game state that we have in the data set. Another thing that we set as an assumption is that we believe that charts should reflect a big picture based on the underlying music, and also how the chart designer is designing the charts. We say that there's a big picture out there, but what actually consists of a big picture? There's a lot of things that can be included here. It can be repetitive patterns, it can be consistent instrument choices, and can be ultimately the understanding of the music itself from the chart's creator. So let's summarize them. Okay, so after many experiments, we decided to go with this format of chart summary. It's a little confusing here, but for each note, we created several summaries with a different time window. We start from having summarizing information from half a measure before the exact note onto 8 measures for that exact note. For each summary, we look into how frequent for each class, for each instrument class, a note is playable or non-playable. And we use this information to calculate a bunch of scores for each individual note. After we extracted this information, we then proceed to apply this information along with a new piece of music to generate something. By first, start looking at whether they are playable or not. For that purpose, we look at several models. The two models that we look at most is LSTM versus feedforward one. The LSTM network is the previously state-of-the-art used by the learning to choreograph people, and the feedforward model is what we have designed for this work. Here's a brief overview of what we have used in the evaluations. On the left-hand side, you can see the feedforward network. It's just a bunch of fully connected layers with regular layers in between. And for the LSTM layers, for the LSTM model, we decided to go with a single layer sequence to sequence model. Of course, with regular layers in between too. After that, we talk about the note. I will be talking about the note placement part. So as you can recall, we were talking about we should be placing notes when we decide that they are playable onto the actual stage to decide which control it maps to. We realized that it's actually the unrestricted PCG part of the whole process. So we decided that we go with the same network but apply some rules on post-processing to make the chart more reasonable. We have talked about what our pipeline is. Let's look at how efficient, or to say how well they perform in our scenario. But before that, we need to look at a problem here. So as you have known already, it's a pretty challenging problem to evaluate game stage. And it's even more challenging to evaluate the rhythm action game stage because there's limited work in this paradigm. There's of course 2 possible ways to do that. The first one is of course automatic. The second one is of course non-automatic. However, we look at the manual method and we realize that there's a need for a lot of human experts, especially in the chart creating community, to make it possible for us to create a manual evaluation results. And this prevents us from trying a lot of different sets of parameters and methods and of course models. So we decided that we go automatic by using an oracle. So when we say that we want an oracle, or to say that we want to do the whole thing automatically, we need to design that actually. So we look at a paradigm that instead of generating something using a normal piece of music, we literally just extract the style information from a piece of music and reapplying it back to see whether it generates something that compares that is similar to the original chart. We use precision which is how accurate it predicts the playable nodes, and record, which is how many playable nodes the model picked up, and also the F1 score, which is the harmonic mean of the two. Overall speaking, if the F1 score is higher, the model performs better. Also, we focus on the playable classification part because this is, again, this is the restricted PCG part that we are interested in. So we have other baselines here. We have things like a random baseline, which classifies, every node, as a playable, 30% of the time, because there are 30% of the time in the ground, 30% of the nodes that's playable in the ground truth. And we also had an all playable baseline, which is of course predicting everything as a playable. We also have LSTM model L0 as a baseline. We also created a self-summary feed-forward model, which is different from the normal feed-forward model in the way that instead of using the difficulty curve and the chart summary, it recursively takes what it generated as the information from the style, and generate the difficulty curve and the style by itself. And we also try different sets of embedded features for both the feed-forward and LSTM network. We build a data set by ourselves containing more than 1,000 charts, OTC game stages from more than 300 songs. They are from data set from an event, a game chart creating competition event back in 2011. And overall speaking, the chart quality, they are redeemed as the highest possible homebrew human-made charts out there at that year. And this audio, and of course, audio sample classification out there is trained on a completely different, unrelated data set, but it's still in the rhythm action game field. Let's look at the numbers here. A lot of numbers here, but I would like to point out, highlight something here. So as you can see, with summaries here, by embedding these summaries out there, both models, both the feed-forward models and the LSTM model receives a significant boost. However, it's our feed-forward model that received the most boost out there. And we realize that although the LSTM is picking up a higher precision, it's not picking up many nodes, resulting in the LSTM model having a very low recall. It's probably like the LSTM model is going very protecting. It's just give only things that it's confirming to. So it results in a worse than F1 score in this case. Another experiment that we did here is style transfer. Essentially, the framework, the pipeline allows us to mix two charts to get a new one. We can use a chart to provide music and another chart to provide the styles, what you say, the difficulty curve and the chart summary. In the mixing process, however, since these two pieces of music are not of the same length whatsoever regarding either their time and their object count, so we have some interpolation in between to make it happen. Here's something that we want to show as the example, an example generating chart. I hope that it works. Let me go on to the meat part. So as you can see, our generator is capable of generating something that looks interesting as a rhythm action game state out there, just by providing a piece of music and something from the real data set. notice that there's something like stairs out there, and there's like patterns, interesting patterns in between, meaning that the generation model is capable of picking up something that is occurring in the original data set. Okay, let's head back. And so as you can see that we generated some chart, we had some results, but we really wanted to have more. So the first thing, the things here we want to work in the future and we want to look into is first, of course, human evaluations, since we didn't do that yet. And also we want to substitute the original rule-based difficulty model into something that is not with a rule. And we want to go further into the style transfer paradigm. And ultimately, we want the human to be in the loop to let them being able to change the style and to make it possible for co-creativity application to happen that allows chart authors to create the chart, the state they wanted. Finally, I would like to present some takeaways with you, share with that. So the first thing is that this mentioned game state generation can be treated as a restrictive procedural content generation problem, and the feed-forward model with these summaries and difficulty curves seems to be able to satisfy these restrictions. And also the ability to let the user manipulate the styles is key to let the chart authors adopt these systems to overcome the skill limitations in the future co-creative applications. Thank you, and the code is online. Any questions?
I have one question.
Yeah.
In the game, you adjust the movements of the hand when you press. Can you consider the time that it has to stay pressed until you release as well? Like a more complex game. Like if you press a node, you consider the length of the node as well, the duration.
You mean this one?
No, the last one.
Oh, the generated ones.
Yeah.
Sorry for that. What's the question again?
Yeah, it's not only a matter of pressing. In those games, when you press, you have to stay pressed for a certain time. Do you consider this as well?
Yes, I think you're asking for the non-pressing nodes. So for the BMS paradigm, or to say the Beatmania paradigm, it's not the case that the non-press node are introduced. Very early. What's that?
The very last slide.
Yeah, the last slide with links.
You mean which one?
With the links. Yeah.
Oh yeah, link to the code, of course.
That's one.
Oh yeah. Yeah, so in our data set, there's actually no long nodes out there. There's a few, but we decided that in the data processing, during data processing, we decided to treat every single long press node as a node in the beginning to simplify the process, because there's probably like 0.5% or less long nodes in our data set. But definitely we'll be dealing with that later.
Yeah, but it's adapted. Is the framework adapted? Can you extend it for including new things, new features?
Say that again?
Can you adapt or adjust the framework for including new?
Oh yes.
Is it simple to do it?
Yes. So the point here is that we just need to have a different classification out there. We are actually working on integrating long nodes into the system now. Thank you.
press the little bar to your right, there's a little screen under there on the right, against the wall. And if you're using HDMI, it's like HDMI. That's putting down how it works. Yes. All right.
Alright, hi everyone. Sam Snodgrass. I'm going to be talking about some of the work I've been doing on automatically extracting tile types and level representations from images. And following the theme of the conference, this is very much a towards paper. Much like Matthew said, it's a load bearing towards that hopefully be covering a lot of the issues we run into. So if you're familiar with me or my work, you know that I'm very interested in PCG through machine learning, and really just kind of trying to build up these generative models of level domains. And so there's kind of these three main components of PCGML, right? There's how you represent the content, so that's the training data and the output data. There's actually building up the model, what models you're using, the algorithms you're using to train, and things like that. And then the fun part, the actual generation of the new content. And there's been a lot of work on this middle bit. So there's my work, Uzal's work, Somerville's work. People have begun exploring using GANs, wave function flaps is this cool new thing. And so there's a lot of work in exploring what kind of models you can use, how can you train those models, and what are the different things you need to do for that. And similarly, there's been almost as much work in the generation side. So each of those trained models have their own kind of generation algorithms. And in addition to that, there's been work in looking into how do you blend those models to get new and interesting output. How can you constrain the models to generate content that you actually want, and things like that. Where there hasn't been much work is in exploring this content representation. So there's been most of the work that's been done in PCGML has been in there's Mario and nothing else. No, so there's Mario, there's Legend of Zelda, Kid Icarus, Lode Runner, and that's pretty much it, right? Particularly for level generation. And there's been some work in trying to like expand this. There's the video game level corpus, which tries to gather as much training data from different domains as possible and represent those in a few ways. And obviously there's been a lot of work in like analyzing and evaluating what like good generated content is and how we can determine what makes good content good for some definition of good. But so the problem here is that we're building up these machine learning models, and like the grand vision here is that, oh, we can build up these models, and once we have a good model or a good approach, we can apply it to a whole bunch of different domains, and we won't need to do a lot of like manual work there, right? We'll have the models and we'll be good. But that's not really the case right now, right? We're building up these cool models and then seeing how good they generate Mario levels, which is great for comparing between the different models. There's obvious value there in saying like, oh, the LSTM approach generates levels like this, and the BaseNets approach generates levels like this, and isn't that interesting? And that is interesting. But in the long run, we really want to be able to expand out into these different, into more domains, and to make that, and to make PCGML really as accessible as possible. And so how can we like open up PCGML to be easily accessible in new domains and easily applicable in new domains? And so the work I'll be presenting is kind of a step towards that in extracting level representations and specifically tile-based level representations in new domains given given just level images. Important to note that there has been kind of some work here in so much as trying to identify what like the different semantic elements of a level are and how they relate and things like that with what is that Questionnaire collective with Somerville and others. But where they're using a lot of like causal relationships and gameplay data and things like that, we're kind of coming at it from a different angle where we want to start with just the structural information of the levels and see if we can use that structural information for how far we can get with that structural information in order to kind of estimate what the semantic elements of the levels are. So the pipeline we proposed for this is here. It's a lot of information right there, but at a high level, what we want to do is basically feed images of levels into this pipeline, find out what the unique like sprites are, train some model on that information, do some clustering, and spit out the like semantic, or at least like groups of different sprites, and treat those as the tile types. So in more detail, at the first stage, we kind of just want to get what those unique elements are, right? And that's pretty straightforward. We just feed in a level, slice it up into bits, and figure out what the unique bits are, right? And so this requires a little bit of domain knowledge, right? We need to know what size chunks we should be using. In most of the domains that PCGML has explored thus far, kind of just like 16 by 16 pixel bits works there. And then once we have this set of unique sprites, we treat each of those as like kind of an intermediate tile type and use it to re-represent the input levels. And so what that gives us is a huge set of tile types, which is not really feasible to train like a good model on for building up these level generation approaches, but it does give us some information. And so using these intermediate representations, we can feed them into some PCGML approaches to try to extract as much information as we can. In our case, we use like the tile distributions. More specifically, in our experiments, we use a Markov random field approach. That's a little switched from how we would usually train it. So instead of learning the distribution or the probability of a tile type given its surrounding, we want to learn what the probability of a surrounding is given a central tile. And what that lets us do is more easily reason about what different types of situations these particular intermediate tile types occur in. So after we build up that model, we can do some clustering. So in our case, we use a hierarchical clustering approach using basically the point of the maximum distance between two distributions as the distance between those elements, and then specify how many clusters we want, and that gives us the representation. So then, using these clusters, we can go back again and re-represent the input levels and get some final converted output level that we can then feed into an actual PCGML approach to generate new content. Now, to evaluate our approach, we use Mario. And we use Mario for a reason. Because a lot of work has been done in generating Mario levels and in representing Mario levels, there's a few different representations that we can compare against. There's kind of the simpler representation, which uses a handful of tile types and kind of abstracts away some of the differences, like particular enemy types or different, like, what might be inside of specific blocks, and it abstracts those away to single tile types. And then there's a more complex representation, which I've used in like my more recent level generation stuff, that really tries to give each unique element a unique indicator. So the different enemies have unique tile types, the different block types and their contents have different tile types. And so the idea here is that we can use our pipeline to pull out a set of, or to estimate a set of 7 tile types and a set of 15 tile types, and then compare those sets against what the manual or like the ground truth representation is. And starting in the simple setting, so on the my right, your left, we have the manual definition of what the different sprites correspond to, and on the far side, we have what the clustering results are. And I'll start with the bad news. So, if you're familiar with any of the level representations or the PCGML work, then you can probably tell that those first 2 clusters are pretty meaningless, right? There's a lot of noise, there's a lot of different elements in there. In the top one, there's a few Goombas and a few other enemies, but also a bunch of just background tiles, and then a few like bricks and blocks. And similarly in the second one. But good news is, or better news I should say, cluster 3 and 4 do kind of have mostly semantically similar tiles, right? In number 3, we have these different blocks with different contents inside of them, and also an empty tile. And then in cluster 6, we have these 2 pipe tops, and also an empty tile. So you might be sensing a theme here, but it's able to at least somewhat group these semantically similar tiles, even if the clusters are a bit noisy. In the more complex setting, so again, closer to me, you can see the manual setup, and on the far side, you can see the clustering results. And similar problems encountered here, right? So clusters 1 and 3 are pretty mixed with what actually is showing up in those clusters, and also a lot of the clusters are just like individual background elements, which occur pretty infrequently in the training set, but occur only in very like specific situations. And so it tends to, the distance metric that we're using tends to just kind of say, oh, this always happens in this way, it must be its own thing, which is part of the issue of using structural information without the actual gameplay interactions. But some of the better results here, again, clusters 9 and 10, we can see it does separate out those pipe tops. And in cluster 4, same as one of the previous clusters, it does group together those different bricks. And also we get a nice part of the flagpole, which is its own kind of thing. And so some of the problems that we ran into, obviously it struggles with background tiles, which I kind of expected going into this. So because it's only learning the structural information and it's treating basically
a brick tile, which the player can interact with, the same as a cloud tile, which the player cannot really, then since it's treating those the same, it has a hard time differentiating what are the important differences between them if we're only looking at distributions. And so moving forward, we want to look at more robust distance functions, as well as more, maybe more expressive and more interesting clustering and modeling approaches, as well as including more information into the actual clustering, as opposed to just the tile distributions. Maybe some global properties about where those tiles tend to be occurring within the levels, as opposed to just this hyper-localized information like that. And second issue, we're only doing static analysis. And this is something that I believe in Guzdial's work, they talked about this static versus dynamic analysis. And in our case, we're only doing the static analysis, but incorporating in some of that gameplay information, how the player's interacting with these different elements, or some kind of reinforcement learning agent into this could really help out. We do want to be careful to try to limit the amount of information we need from the user at this stage. If the goal is to make it easier to generate and create annotated training sets, then requiring the user to write a script for an agent that can play through levels doesn't really accomplish that goal. But there's been interesting work in using reinforcement learning agents in like general game playing. So trying to incorporate those maybe into this framework so that it can be generally applied across different domains without having the user need to specifically define those agents. Could be interesting. We need a deeper evaluation, which was a point a lot of the reviewers made also. Mostly the evaluation we have at this point is kind of just manual inspection of what are the clusters, how do they compare to the ones we know. But in particular, if we're going to be moving to domains that haven't been used before, then we're not going to have that ground truth, right? Or at the very least, we're going to have to generate that ground truth ourselves, which is kind of defeats the purpose, right? So we want ways of evaluating how good the results we're getting are. And one way to do that is to actually feed these levels to an approach and see what comes out. Something that needs to be considered here is that the translation between the clusters and the actual sprite representation in the levels themselves is not necessarily clear. So you saw those noisy clusters. If we choose cluster A, which had as like the tile type in a level, but that had Goombas, it had pipes, it had empty space. If we generate a level that has an A, what do we actually put there to like look at that level? And so this kind of goes back to refining the clustering, trying to make sure that those clusters are as like clean and as pure as possible before going out to this stage. And obviously, comparing with the other work in the field, mostly the only work in this like specific topic has been like, what does that question mark block do?
In the first third of my dissertation, but it's not in a paper.
Yes, so I'll also look into that then. But yeah, so comparing with that and seeing like what, how close can we get to that more semantic reasoning with only using the structural information and seeing what the interesting differences there are. And then obviously we only looked at Mario, which is a problem in and of itself. So expanding this into further domains and then actually being able to see how this can work in domains that haven't been explored before and see how
see how the pipeline actually works for users. So maybe running a user study to see if the goal is to make PCGML more accessible, does this actually help with that? All right, so we introduced the pipeline. We kind of treat it as first steps towards automatically extracting representations. We have modest results, I'll say, is a nice way of putting it. But we think that it's a good, kind of a good step towards what we're hoping to do in the future. And like introducing it out to the field and saying like, this is something interesting that we should be looking more into because there hasn't been a ton of work here. And I think there's a lot of room for contributing there. Okay. All the things that I was talking about. And yeah, so happy to have questions now. And if you want to contact me, here's my info. Yeah.
So you said you're using markup random fields?
Yes.
And you mentioned that was, how much of improvement did you see from that?
How?
I mean, why did you choose to go ahead with that versus the more usual way?
So I'm not sure what you mean by the usual way.
Do you know how much of advantage you got from looking at the probability of surroundings based on the current tile versus looking at the current tile based on the surroundings?
Okay. So I didn't compare results between the different ways you could set up the random field. Pragmatically, I set it up that way in order to make the computations and the comparisons easier.
Okay.
So by conditioning on the tile as opposed to the configuration, the table becomes wide instead of long. And it lets me more easily compare, like, this tile shows up with these different configurations in these certain ways, whereas the other way it would be a lot of jumping around.
All right then, thank you. So it is time for a 30-minute break, after which we'll be back with 2 more papers to wrap up day 1 of EXAG. I'm going to put the stream on going live shortly in the meantime, but see you all in a bit. Yep. All right, everyone, we are back. We are live. Hi, Internet. Thank you all for watching. This is our last session of the day. We've got two talks, and then we'll be ready to see you all tomorrow. So take it away.
Hello everyone, I'm Henry, and I'm going to be presenting some stuff I did over the summer and I'm going to be presenting some stuff that I did over the summer at NC State. So, procedurally generated murder mystery. So the background, in detective stories, there's the narrative and there's the deductive components. And so narrative is the story. You're consuming it for the story, the characters, whatever. But then, along with that, part of the fun is trying to figure out what the solution is going to be in the end. And the limitation there is that once you know the solution, you know the solution. You know who done it, you know who done it. There's no going back on that. And so while you can read a book or watch a movie or play a game again if you like this story, the fun of the deduction is lost to a certain degree. And this is especially an issue for games where replayability is something that you want to have as a priority, and especially for the sort of games where the deduction is the gameplay, because then that's the game. So my purpose with this project was to increase replayability in detective games by procedurally generating the scenario so that there wasn't a single solution that you know once and it's done. And so generating the scenario using AI, and this was using a system developed by Marcus Bager called Ostari, which I will expand on later. And so using AI to ensure that the murder scenario generated is reasonable and to ensure that it's solvable. And then Ostari also includes epistemic modeling, which allows the deduction to adapt to an arbitrary scenario. So a brief introduction to epistemic logic. It's based on agents, each of which has a set of possible worlds. And so in this diagram, this is the actual world. And so the state is the values of these two cards. The players are X and Y. And so X knows what, and this is the hand that X has, and X knows what's in their hand, and Y doesn't know what's in X's hand, but Y knows that X knows what's in their hand. This is all a bit complicated. So the arrows represent accessibility of one world from another. So Y knows that if this is the real world, then X knows that this is what's in their hand, and also believes that these others are possible. So all of them are connected by arrows because Y labeled with Y, because Y believes that all of them are possible, but each one is connected only to itself by one arrow because Y knows that X knows which one is the actual world. Does that? Yeah. So Ostari uses this system, uses this framework. It's a framework for building games which have multiple players, and each of them has a set of possible worlds that they, think are possible, and actions can affect what worlds they consider possible differently from how they affect other players and from how they affect the world. So actions can have known parameters, and these are like public to the agent, and it will adjust its possible worlds based on what parameters are known, and then unknown parameters, and it will basically say that any possible world that could have been generated by taking that action with any possible value of that parameter becomes possible. So if you don't know what color someone's hair is, for instance, you might have a range of possibilities for what color their hair is, and then you see them and you know what color their hair is. But then they dye their hair, and if the color that they dyed their hair is a known parameter, then you still know what color their hair is. But if it's an unknown parameter, then this expands out all of those possibilities again. And it's based on Alexandru Baltag's action logic, which is a logical framework for this, but Ostari is a much more beatable and writable version of this. And so it's much more suited for actually creating games. So the system that we created for the game uses Ostari in this bottom layer here, and then the top layer is other systems. And so the player accesses it through a web browser. There's a web server UI run in Python, which takes the output from the belief manager in Ostari and sends input into it. And then there's Python, which generates the characters. I'll go into more detail about how it does that. And the story input, and that is the actions taken by the characters in Ostari by the other AI players. So it uses Python to generate values for the different properties of the agents and substitutes these into a template file. And so there's physical properties, which are hair color and height, and a motivation. And so most people have no particular motivation and are just going to go around doing whatever. But then there's one person whose motive is to murder another individual, and then there's one person whose motive is to steal a gem. And if they get the opportunity to do these, then they'll do that. And it also ensures that each agent is distinct, because if you have two agents with exactly the same properties, you can't tell which one of them committed the murder if you rule it down to only them. But if they're all distinct, then it's possible to rule out people properly. So here's an example of what it would generate. So Sylvia's tall, has black hair, and has a grudge against Porter, which means that if she's in the same location as Porter, he has the option to kill him. William is tall, has brown hair, and has a gem, and so the gem will be in his room. And if Valcian wants to steal the gem, and if she's in a position to do so, then she will. And then Porter and Dorothy have no particular motivation, and neither does William, but they have physical properties, and these physical properties are, there's no two that have the same pair of hair color and height. And so then the agents generate the scenario. They take, Ostari gives them a set of possible actions based on their properties, which include things like their location and their motivation, and then they'll take actions based on these properties randomly, and then the motivation property unlocks new possible actions. So you can't murder someone if you don't want to, because this is a murder mystery and not a manslaughter mystery. And so we want to ensure that someone does in fact get murdered. Anyway, and you're not going to steal something by accident either. And so actions initially generate physical evidence of the crime, if it's a crime, but then other characters can witness the crime, and in this case it actually deletes the physical evidence so that it's not too easy for the player, because if there was both physical evidence and a witness, then there would always be physical evidence, and you could just go around searching the rooms and never talk to anyone, which is not what we're going for. So here's a set of possible actions that could be generated that would produce a scenario in this. So Valcian goes to William's room, she steals the gem, and she changes her motivation from stealing the gem, because she no longer needs to do that, to hiding the fact that she stole the gem. And Sylvia runs into Porter in the hallway and kills him, and this leaves a body in the hallway, and maybe some of her hair got left on his body, and that produces evidence. Or the angle of the wounds shows how tall she is. And she changes her motivation to hiding the secret, but Valcian, having left William's room after stealing the gem, is in the hallway, and so she sees Sylvia's hair color, but only gets a quick glimpse and can't tell how tall she is, and so she can't identify her uniquely. And so then, to solve this, you would have to question Valcian to find out Sylvia's hair color, to find out the hair color of the murderer, but Valcian wants to hide the fact that she was stealing the gem in the process, so you would have to find out that she stole the gem in order to get her to open up. So the game goes through a web-based interface, and the players have options of what to do based on their properties at the moment, mostly based on their location and who else is in that location. So they can search their location, they can talk to other people in the location, they can move to other locations, and generally the other NPCs will be receptive to questioning, and if they've seen anything, they'll say so, unless they have a secret to hide, as in the scenario I described. And then finding physical evidence will find you physical evidence, but that may not be enough to uniquely identify the murderer. And then Ostari, as you take these actions, you find out new facts about the world, and Ostari models what your possible worlds are, and so the interface lists the information that you've deduced so far, so that you know what you know, so to speak. So here's the interface, and you can see here, this is the set of possible actions. You can accuse anyone at any time, but this will fail if you don't actually have enough evidence to accuse them properly, and so that's tracked in-game by having a belief that a true belief that they are the murderer.
Oh, heck.
Wow. In some of the rooms, they have a timer on how
Yep,
long the presentation
I set it
runs.
for an hour. Not long enough. Because I miscalculated how long this would be going for.
Yeah, I just found that in the main room as well.
Yeah.
Yeah, it's like a little thing. How long is your?
That's a good feature.
I have a question.
Yes.
So if witnessing a crime deletes physical evidence, if someone witnesses the murder, what happens to the body?
The body stays there.
So it doesn't delete that physical evidence?
Yes, no.
Okay.
If they witness the crime, they witness something about the murderer.
Okay.
Not about the body. This can change the in-story properties of the body, like the wounds being able to tell you how tall the person is, but it doesn't change the mechanical properties of the body, which is just a person who has the dead property.
Sure.
And you know, being dead means that you can't be questioned and so on, but it does mean that it opens up the opportunity to examine the body and see if there's anything.
Is it possible for the murderer to kill a thief, or for them to be?
Yes, it is possible. It is not possible for the murderer to be the thief, but it is possible for the murderer to kill the thief, in which case you just don't find out anything about the thief.
Hey, we're coming back.
It's like a gas window.
Yay! Thank goodness. Yeah, it's warm enough, it's fine.
Anyway, so right now the player is in Porter's room, as you can see, because they had the option to search Porter's room and to move to other people's rooms or the hallway or the deck. They can accuse people. Nobody is in the room who has anything in particular that can be done. So
You can accuse Porter even though he's dead. Suicide.
That's surprising. This is a bit of an old screenshot, so that might have been a bug in that version. And so here's like the output of the actions. So the bold one is the most recent action. You observe the properties of each person so that you don't necessarily immediately conclude who it is upon seeing the body if you haven't actually gone and looked at the people. So the player looked at the body, and this doesn't indicate the hair color, but it does indicate that the killer was short, and then looked at the different people. And so you can see here, these are the facts that have been deduced. This is the only fact you know about the killer. And this says Dorothy isn't the murderer because she's tall and you saw that the killer is short. And so that's an example of how the Ostari deduction will automatically, the Ostari belief modeling will automatically update those deductions. If you find evidence that contradicts someone being the murderer, then you know that they are not the murderer. And so that means you can't accuse Dorothy because you know she is not the murderer. And so you can only accuse Sylvia, Valcian, or William, or theoretically Porter, but that would not work. Right. So the successes of this, scenarios are always solvable. The procedural generation does work to do that. So there always is enough evidence to find who the murderer was, but not so much evidence that you instantly figure out everything. And then all the agents are always distinct and so on. And it does produce multiple distinct ways that the deduction can play out. So for instance, if no one witnesses it, and you go and look at the body and see what the height and hair color of the killer were from the physical evidence of that, then the rest of it is just going around and looking at each person and seeing who matches the description that's consistent with the physical evidence. But if someone sees it, then you have to go around and question everyone as well. But if someone sees it and they happen to have been the thief, then you have to go around and question people, and someone will be not forthcoming, and then you have to go and search and find proof that they were in fact the thief, and then you can go and accuse them of being the thief, and they'll say, okay, fine, and here's what I know, and then you can learn who was the murderer. And it's relatively easy to extend the system by adding further properties. So this, as I mentioned, was my summer work at NC State, so there was only a limited amount of time to implement this, but with further work it would be possible to add more detail to the scenarios. The limitations of the version as it stands, though, is it only has a small number of properties, which are the hair color, the height, and the motivation. And so this is for a few reasons. Basically, there's a lot of possible values for the properties when you have 4 people, each of whom has multiple possible values for the properties. If you have, it gets into the tens of thousands relatively quickly, and then you have tens of thousands of possible worlds, because you have like 2 to the 4th times 3 to the 4th times 2 to the 4th if you have 2 properties with 2 options each, and 1 property with 3 options across 4 different people. And this gets to a lot of worlds, and so you have to work around that and optimize the way you write the code to avoid having this exponential explosion in possible worlds that makes Ostari unplayably slow. And so the consequence of that limited number of properties is that at the moment there's only a few meaningly distinct playthroughs of the game, but there are a few. And the amount of use of the AI systems in Ostari is limited because of similar performance issues. Right now it's basically they take random choices, and the available choices are impacted by what their motivation is. But Ostari also has a pretty sophisticated AI planning system that just is hard to bring to bear in this particular case, but further work could be done to expand that. And then sometimes the tracking of deductions is unintuitive, and so if we go back and look at the interface So prior to this version, older versions had this issue even more, where you could figure out that someone was the murderer simply by ruling out everyone else without looking at or talking to the actual person you ended up accusing, and so it would be very sudden, and without the interface feedback of who you had ruled out as a possible murderer. This was pretty unintuitive, and it's still something that could be improved on, but it's better than it was. Now that you know, you can see we've ruled out all these other people as possible murderers. And in the future, yeah, increasing the number of properties and doing the work to make sure that this doesn't result in an exponential slowdown of the game, making motivations have more complex effects and more complex ways of finding the clues, because right now it's just searching the room, and making more use of the AI would be the main areas that future work could go into on this project.
How do agents, you said that they take actions at random, for example?
Yeah.
How did Balsian know to go to William's room to get the gem?
So she took actions randomly and moved around between the rooms, and once she was in William's room, she had the option to steal the gem, and so stole the gem. Part of the thing is that the procedural generation of the scenario using these AI agents takes place before the player comes in at all, and so it's not visible to the player, and so it's possible to have them just take lots and lots of actions in a way that wouldn't really make sense if you were showing it to the player.
Mm-hmm.
And so they just bounce around, and eventually it comes up in a way that turns into a murder and potentially the theft of the gem and so on. And at that point, it ends. And so, that's because it's not visible to the player, it's possible to just have that going in the background. And similarly, with the deletion of physical evidence, like that wouldn't make sense if you were showing the scenario of the generation to the player. The idea is just to result in a scenario that works out. And so the main reason to use AI rather than to just like randomly generate these things ahead of time is because it could be extended in a much more robust way using this AI-based approach to more complex things, even if the current version is very simple. Yeah?
You mentioned that adding more properties would enlarge the search space quite a lot, but that it would require substantial work to reduce the number of possibilities again. Mm-hmm. What kind of work were you thinking about there?
So one approach that I took in this, because even with the properties that we have currently, across 4 people, it does come out to like tens of thousands of possible worlds. So one approach was, rather than having each property just have a range of possible values, setting it to an unknown, to a value which was just labeled unknown, and then this is a definite value which it has, but then it gets set to something else, and this required some somewhat unintuitive workarounds in the actual code to generate it, but similar solutions for further properties could work. Maybe coming up with something more robust. I don't know exactly what that would look like.
And more complex motivations?
Right. Right now the motivations are just like kill this person, have this, like steal this gem, whatever. But you might have a motivation which is like get a lot of money, and then you could say run into a person who has a lot of money and murder them and take their money, or find the gem which is just sitting in someone's room and steal that, and then that would resolve the have a lot of money thing, and then someone else might have a different motivation that caused them to murder someone. And in that context, it would potentially be possible to have it leave evidence of what their motivation was. Because right now, there's only one motivation that can lead to murder, but if there were multiple motivations that could lead to murder, then you could have it leave evidence of what their motivation was, and then the player has to find out what the motivations of each character are. And this was something that was originally planned to be implemented, but there wasn't time.
Questions?
Can I please borrow the mini DisplayPort adapter that
Black one?
There you go. Yeah. Thank you so much. Whoops. Oh, it's not. DisplayPort adapter.
I know.
C-port adapter.
Yep.
Oh. So you have a different connector than I do. Does anyone have a mini DisplayPort adapter?
Chris Martins has one in the other room. I'll go ask.
Oh.
Team sport.
Thank you so much.
HDMI for mini display? Is it HDMI for mini display?
Yeah, I just need mini DisplayPort on one end. Lovely. Thank you.
Let me go get it.
Okay, it's Chris is presenting right now.
Just take it.
There.
Are you sure that HDMI is
Oh, it is selected. No, that's very weird with the head. I see. We have an intermittent connection.
That's good. It's just, play to the presenter box.
Really?
Right. We may end up wanting to punt the live demo. I'm not sure. Maybe. All right.
Okay.
Good.
So,
What you stand
what is the worst thing you have ever done at a conference? What is the worst thing you've ever done at a conference? Okay, so a lot of the work that we do, a lot of the work that this community does, that the people who are interested in this kind of gameplay, this kind of operationalizing and leveraging AI for interesting gameplay, we look at games that are like really cool. We could start with things like Dungeons and Dragons, or we could get really neat and think about like what are really cool free-form things. What's really cool? Like lots of people do improv acting. Lots of people will think about what are the things that we like to do creatively that involve making stuff, making stories. And then we're like, all right, well, we're gonna steal those ideas. We're gonna try to create those things. And sometimes that manifests as people are like, I'm just gonna make a full. It's gonna be an improv actor. It's gonna improv act alongside you. And then we're like, okay, that's the thing we're going to make, and we're going to see what that looks like, what that gives us gameplay-wise, what that gives us as designers. The really big problem with that is that like improv acting is, and writing and any kind of creative pursuit is already really hard. Like most of us are not good at acting. I don't want to insult all of you. I'm gonna use myself as an example. Most of us are not good at these creative things. This is why we're computer scientists. Just kidding. Sorry. And so like we try to make approximations of these things, and that even in and of itself is like kind of meh. But like eventually we will have human level AI, and that will be great, and then we can have improv acting agents alongside us. But for now, what we want to do is we want to say like, what are these things, and how do we steal their ideas in ways that are meaningful, that we can be like, this is a good start, this is a good approximation of a first degree attempt towards getting that sort of experience for our players. So, leapfrogging ahead, let's talk about freeform story games. These are games, so Dungeons & Dragons is an okay example of this. You have a GM who will ask you to do things, but D&D, Pathfinder, Call of Cthulhu, etc. These are still pretty crunchy. You're still rolling dice, you have numbers, you have tables, you have rules, and there is a physics in the game that is explicated to you in the manual that you need to know to quote-unquote play the game correctly. It's not quite as heavy duty as even some of the more interesting, like traditional board gaming games, where it's like, these are the rules and you play the rules and there's no, not explicit freedom to expand and express yourself. But the crunchier sides of the role-playing games, you don't have as much freedom to express. By contrast to that, you have freeform games, you have games like Fiasco or Dread, and we're going to talk about Dread, where the whole point of the game is expression. The whole point of the game is you've got a very vague set of physics, but mostly you have a premise, and your job as the player, the whole point of playing the game is to express yourself, is to do stuff. It's like, whatever, like we don't care what you do, this is the way it starts off, and you go and your friends, and you make an experience, you make a story. And because of that, it's often going to be extremely unlike anything, like who's played Fiasco, actually? Okay, it's fabulous, and weird and zany, and I've never played any two games that are the same. Most of them do, most of them end in like complete disaster. Speaking of which, let's talk very briefly about Fiasco. Bully Pulpit Games, Jason Morningstar, you create a Coen Brothers style disaster story. So like the premise of the game is you sit around a table and you use a very vague set of rules to create connections between you and the two people sitting to your left and right. And then you do scenes about each other. And that's all there is to it. Like there are a couple of rules for how scenes can be set up, but mostly it's like you do these things and your characters have these vague motivations, and then you just kind of roll with it. And by the end of the story, like half the table is dead, the other half is like wanted by the police. Maybe someone ends up okay and alive and rich, but like it's a wild ride. And you can see, like immediately you can see why these extremely ambiguous circumstances would necessitate human level AI. And we don't have human level AI. So what's my point? Let's talk about Dread. Dread is it's structurally analogous to Fiasco insofar as that it is a free-form narrative game. Dread is all about horror, it's about suspense, it's about making people feel kind of uneasy. And what's particularly cool about Dread, among a litany of other things, actually, I'm going to talk about the less relevant one. You use Jenga towers instead of dice. So like, if you have to do a challenging thing, you pull a block off the Jenga tower, and if the block falls over your character's, like you're dead. It's like that's how you die. But if you like, which means there's building tension. I'm really excited about Dread, but I'm not going to talk about Dread. We're going to talk about the questionnaire in Dread. The way that characters are created in the game is you are given a sort of open-ended, sort of loaded question-heavy questionnaire, which says things like, what scared you most as a child, right? Like this is not like, what is your strength, what is your agility, what color is your character's hair? It's more like there's a lot of implication. All of these questions are loaded, right? In what ways would you be better suited for your boss's job? Like that's a heavy-duty question. If I asked, like if we went out for a beer after this, and I was like, hey, so what do you think you're better at your boss than your job? Like that's like it's a very personal thing. There are a lot of things going on. There are a lot of assumptions being made by me, the question asker, and about you, the answer of the question. And this is really, really cool. This is how you make your characters in Dread. This is from one of the pre-rolled campaigns that come with the booklet. But if you are the GM for Dread, if you want to give someone an experience, you will come up with an interesting set of questions that you use to ask your players and say, hey, like, let me flesh out your character by asking you these like really awkward questions. And not only are they loaded, not only do they have presumptions, right? Things like, in what ways would you be better suited for your boss's job? That presumes that one, you might be a little arrogant. Two, you have some kind of job where there is someone above you in the hierarchy. But the way you answer this question says a lot about your character. If you say, well, I'm better at my boss's job because my boss is terrible, but also like I'm a really good mechanic and so on and so forth, like the ways in which you answer the question and the fact that you answer that question in general, there are a lot of implications. There are a lot of things you could write down about your character just by the fact that you chose to answer that question. You don't actually have a choice to answer the question in Dread, but I digress. So, Dread, we like Dread, it's cool, the questions are great, but in a digital game, again, we're talking about stealing good ideas from a digital game because we want to afford some kind of experience to players of a digital game. So you would, if you were producing content, if you were being the author here, you would write a bunch of questions and also their possible answers, and then there are a bunch of implications, right? As I mentioned with the boss's question, or how did your father die, right? The fact that the question is being asked implies some things about the world, and it's pretty easy to annotate these things, right? And if you have a bunch of answers, you also annotate the things. It's like, how did your father die? I killed him. It's like, okay, your father's dead and you're a murderer, right? And Valcion stole the gem, or whatever the case may be. And so the system in this digital game is going to accumulate implications, both the premises of the questions and also the way in which the character answers them, the player answers them. And then you say, okay, if there's how did your father die, and then it's like, why do you have a good relationship with your father? That's a clear contradiction. So as you're accumulating these implications, you are eliminating contradictory questions, or contradictory answers, or both. If the question's premise is not possible, you can get rid of it. If some of the answers are impossible, you can get rid of them. Okay, that's how you might go about doing that. And that would be if you wanted to make a Dread-like interactive fiction game, which you're gonna have to take my word for it and Ian's word for it. You do want to make an interactive fiction like Dread-like game because it's a really cool game. But this would be like a very, very, very first step. And now going back all the way to like the very first slide where I'm like, what do we want to do? We want to give people cool narrative experiences. This presentation, we are talking about how we took an initial step towards a broader generative game where we're like, this is a game we'd like to make, a game like Dread, this is the first step. If you were less inclined to make something specifically like Dread, you could just use this as an NPC generating tool. Like this could be a thing where you as a dungeon master, you as a game master, like wrote down a bunch of questions or took a bunch of questions off the internet because obviously lots of people will use the system and you'll have lots of content and that's never a problem. And then you're like, that's slightly more interesting than just like, please roll me a table of height and weight and race and strength and agility and so on. You can actually give your characters a little bit of personality if you were so inclined. We were more inclined for the former, but don't let me tell you what to do. So, I'm going to pass the mic, as it were, to Ian, and he's going to talk about the actual implementation.
Should we try and do the demo?
Do you want to do the prototype demo? Wiggle the thing and see if it goes. Yeah, let's do it.
All right. So we forgot to turn on font scaling.
Oh shit.
Okay, I'm going to read to you the questions and the answers, and you call out the answer you want.
Here, put it on full screen.
It is on full screen.
Maximize on play?
Yeah, maximize on play.
Right.
Yikes.
What will you have to drink?
There is scale right there.
Oh, yeah. Trying to scale up, Ian.
Oh, awesome-o.
Unity.
Thank you, Unity.
Yeah.
All right.
What do you have to drink? Okay.
What will you have to drink? 1, whiskey on the rocks. 2, a bottle of spring water, please.
3, a Diet Coke, I'm trying to watch my weight. Or 4, an ice cold bottle of orange juice, I'm parched.
4.
Orange juice.
All right. And so now we have an implication, which is that you like sweets.
When you have trouble sleeping, what do you focus on? 1, the last time my brother and I saw each other. 2, the time I won a big game back in high school. 3, what I'll say to my brother when I make it back.
That's lover.
Lover.
Lover, sorry.
Very different conversation.
Or 4, the serenity of mountain climbing.
4.
4.
4?
Always 4.
Always 4.
Forever.
All right. What could you have done to save your brother's life? 1, taken the car keys away. 2, taken him away from Dad. Or 3, made him move in with me to get out of the neighborhood.
2.
1.
2. 2.
2.
2. 1.
I hear more ones, but the 2s are louder. Democracy.
This is America. Loud.
Oh no. As it were. By the way, we're accumulating. Okay, listen, we like sweets. We have insomnia. We like the outdoors. We're peaceful. We're athletic. We have a dead brother. We have family guilt. We have an abusive father. And does that say we're 24 years old?
Greater than or equal to 20.
Oh, we're greater than. Why?
Because we were going to take away our brother from our dad.
I can't remember now.
Can you not do that at 23?
Apparently not. There are rules.
Maybe they have hard-coded ages in the background. Has certain.
What book?
But read every year on the anniversary of your father's death. 1, the Bible, lowercase b. 2, quote, King Lear, end quote, end quote.
2.
2.
Why are you the black sheep of the family? 1, I married outside of our faith. 2, I like the bottle too much. Or 3, I'm a fucking loser.
1.
2.
1.
1.
Okay, I think 1 wins. How often do you see your family?
It's
1,
because
once
option 4 is not available.
We didn't always author 4 options, but also, as we'll talk about, when we do author 4 options, we will suppress those options if they contradict previously established facts. And in fact, we'll suppress entire questions if the question itself contradicts established facts, or if there are only one possible answer to it that doesn't contradict established facts. How often do you see your family? Once a year, once a week, or never?
Never.
3.
Brother and father are dead.
What holiday is coming up in the United States next week? All right. So, this is a possible you. You are Simone Frost, age 36. About your mother Blanche, you dislike her. About your father Tyson, he's dead, you dislike him, he's abusive, you hate him. Brother Alex, he's dead, he's an alcoholic.
What?
You like alcohol, you
Got a contradiction.
Yeah.
Look, you can both like and dislike alcohol.
Cognitive dissonance.
You like sweets, you like the outdoors, you dislike literature, you dislike yourself, you love your family, you love sibling.
Yeah.
I love
You love a sibling.
A sibling.
Right.
What was the
You
contradiction?
like family, but you dislike alcohol.
You like 2 out of 3 family members, but you love family.
That's an okay contradiction.
All right.
There we go. All right. So that's our high production value prototype. So here's an example what the source file for the questionnaire looks like. What could you have done to save your brother's life? And then that's annotated dead brother, comma, family guilt. And then answer, taken the car keys away, annotated with alcoholic brother. Answer, taken him away from dad, annotated with abusive father. Answer, get him out of the neighborhood, annotated with gang member brother. So then the questionnaire file can also have constraints in it, which as we just discovered, I was missing some of. But some of them are, so Ethan took a trope from tabletop role-playing game character design, which is to say that characters are going to have their personalities defined by choices from a couple of menus. And so one of them is mindset. And so every character is nostalgic or arrogant or peaceful or optimistic or sentimental or prepared or obnoxious or vulnerable or bossy or health-oriented, but exactly one of them. And that's what the unique constraint says. Similarly, every character then has a weakness, an affliction, and everybody's got exactly one of those. And we say simple tastes and posh tastes are mutually exclusive. If you like alcohol, you're over 21. If you're alcoholic, you're over 25. And if you're married, you're over 24.
Oh, that's the contradiction. I was going to say that was the contradiction probably, because they're over the age of 21, so likes alcohol, but did not choose alcohol, so dislikes alcohol.
Right. Well, but this is an if, not an if and only if. So there's also an if and only if, but be that as it may.
But you become an alcoholic after you've been married for at least 10 years.
So the annotation language here was designed to, as much as possible, be legible to people who aren't us. For example, I have a friend who's a writer who I would love to have help us with the actual writing for this, and asking her to start by going offline for a year and learning answer set programming kind of seems like a bad idea. So it's trying to be structured but Englishy. Like Ingold has a whole rant at GDC from 2015 about how source files for IF should absolutely not look like programming code. And if you haven't read it, you should totally read Graham Nelson's white paper on Inform 7. One of the big things is that this means we need to hide bound variables from the writers. So there's a limit on some of the expressiveness we have. In particular, there's limited quantification, because to have quantification, you've got to have general quantification, you have to have bound variables. Logic is an order-sorted logic. Sorted logic means basically it has data types. Order-sorted means there's types and subtypes. It's got cardinality constraints in it, such as mutually exclusive, unique at most, things like that. It has inequalities on reals, and there's a little bit of quantification in it. You can do things like, if you say living family rather than living brother, then that gets treated as there exists a family member who is living. And there are some simple higher order constructs in it. In particular, you can say that predicates generalize one another. You can have negative generalizations. If this predicate is true of an object, of its argument, then this one has to be false. And you have mutual exclusion between predicates. So what happens is the system reads in the questionnaire file, and it compiles all the assertions into a SAT problem. Since the annotations consist only of ground literals and rules, it's already basically propositional. It's not hard to do that translation into the SAT problem. And then we use the SAT solver to answer questions about whether or not whether a given set of assumptions are consistent or not. And at the end, we use that also to fill in values of personality variables that the player hadn't answered the question about. So the SAT solver is a system I'll be talking about on Thursday called CatSat. It's ASP-ish, although the semantics are a little different. It's embedded in C#, so you just drop a DLL into Unity, and you can use logic programming. It allows some somewhat fancier things. It has sort of alpha support for non-Boolean variables, theory solvers for SMT, and then the back end on it uses stochastic local search. So it's not sort of a standard ASP solving kind of algorithm. It's actually doing randomized generation, and so you're always getting a random answer from it. So then the algorithm to generate a character is start with no assumptions about the character. For every question you want to ask them, check for every possible answer to that question whether your current model, your current set of assumptions about the character, plus the implications that are in the question itself, plus the implications of the particular answer, whether those are all jointly satisfiable. Just run the SAT solver to find if it can find some model. If so, is a possible answer, go on to the next possible answer. Do that for all the possible answers. If you end up with more than one answer, then possible answer, ask the question of the player, get their actual answer, and then add the question's implications and the player's answer to the question implications, add those into the set of things that are established about the player character. Once you've done that for all the questions you're going to ask them, then use CatSat to just randomly find a model that satisfies this set of assumptions, which by construction you know has to exist. Fair enough? So, related work. There's been all this great stuff on PCG for ASP for PCG, particularly by M. Smith and Mark Nelson. There's Graham Nelson's white paper on Inform 7. There's Evans and Short's Versus system, which just was an amazing feat of logic-based interactive narrative. And then there have been various kind of semi-digital freeform games where people have tried to do something that's sort of in between analog freeform games and digital games. The coolest of which is Totally Bad News, by far.
Somerville.
Yeah.
That's you, Somerville. I'm the.
Oh, I'm so sorry.
I'm the non-Scottish one.
I'm so sorry. There's a lot of interesting work to do, we think, with bringing interesting analog game mechanics into digital games and trying to develop AI technologies to support that. It seems practical to do at least some limited backstory generation as PCG that then gives you a representation of the backstory that's machine understandable, and then the system can potentially use that to steer the story in a certain way or to customize the generation clips or whatever. And in-engine SAT solving is actually usable, which was not obvious to me when I started this, but every time we pushed a button in the demo, it was solving, I guess just 4 SAT problems, but still. So, thank you. Yes, sir.
When you annotated those statements, was it done by the researchers, or was there a crowdsourced way of annotating?
That was us.
That was us, and we did. Ethan had this idea that he wanted people to be able to tweet at something.
It would be amazing to have crowdsourced stuff, but like, I'm sure anyone in here who's crowdsourced.
Yes.
Yeah.
Yeah, no, I do it. That's why
you asked the question. I'm sure you know that it is nothing but suffering.
What it may not be a bad idea is to put in hand-authored sort of these tags and then use sort of assortment of targets and crowdsourcing to get some notion of like, are these working? So it was not intuitive that there was this notion of brother was a gang member. Mm-hmm. I thought he lived in an unsafe neighborhood.
Yes.
Right.
So like these tags that can add this layer of context to it.
Right.
That I feel can really make the annotation more grounded and can really help.
So are you suggesting that we come up with what are obviously loaded
Yes.
questions with lots of implications, and we put them in front of random people, ask them to provide the implications? So
Yeah,
that-
and sort of like give at least a notion of perception of them. So like
Yeah.
let's say, you know, if I can think of a rating or a ranking task of these annotations, if you have enough in, you may end up have a cluster of it. Then that can actually add. So you know, nothing wins essentially, but you at least have some a score, almost like a propensity score around these notions of tag annotations.
All right, thank you. Yes.
You said with screen solving within Unity and GLL, is that already out there? Or is
That's
that
the CATSAT system.
Okay.
It's on GitHub, and I'm giving a talk on it on Thursday.
Okay, oh, awesome.
And just, I mean, I want to do some expectation management. If you want to do big stat problems, do not use CATSAT. Use ASP. But
you can use ASP in JavaScript now.
right.
Sort of.
But I'm still waiting for someone to actually build a game that does that.
Okay.
Oh, hey! I want to talk to you.
Cool.
I mean, I wanted to talk to you anyway. Yes.
So I haven't used stat solving stuff much, so apologies if this is a dumb question. But is there a space in there for sort of like potential implications, right? Because it seems like a lot of questions directly imply certain things. So like if you have a question like, how long has it been since you talked to your brother? That
Right.
implies that you have a brother, that you haven't talked to him for a certain
Right.
amount of time. But it also sort of potentially implies that there's some reason, like some problem with your relationship there, right?
Right.
So if you did not want to establish that 100% as a fact, but wanted to open up a space where that could be
You can do
an interesting thing to include, is that doable with this?
You can do conjunctions and disjunctions, where
Yeah.
it's like this implies this, and this implies that, and those two things together imply a third thing.
Because that, to me, seems like that creates a really interesting, richer space where you have a lot of things you're not requiring about the character, but you're suggesting as possibilities, or the answers are suggesting those as possibilities.
And then like further questions could.
Yeah, further questions could potentially follow up on that, like let's confirm or deny that this is actually an issue, right?
Well, one of the kinds of things you can do is you can have a variable in the system, which is the reason why you don't talk to your brother. And that the existence of that variable can be conditioned on your not talking to your brother. And then one of the possible answers is just, you've been busy.
Right.
And so then there'd be an issue of whether or not other questions could then sort of contribute to what that reason was.
Right.
Yeah.
I can imagine that you may need, as an author, to see the consequences of the rules that you put in. Have you thought about presenting about this process?
I'm not, you're saying display them to the author as kind of part of the authoring interface, or do you mean displaying them to the player?
I was thinking of to the author.
To the author. Thought about it. Haven't done much with it other than the fact that in the current system, as you're trying out the questionnaire, it shows you what implications have been established. But it would be easy to generate visualizations of what the implications of different propositions are and what questions and answers establish them. Yeah.
So, I'm just wondering, do you do anything with balancing the tree? Like the decision tree structure. Let's say that if you ask a question, to player, let's say, do you have a mom? The player says no, and you immediately ask it, the player, do you have a dad? And if it happens to be the case that the answer was no to, then it's probably like 99% of the question don't have any meaning at all, which means that the tree is becoming very unbalanced. Do you have anything that you do with it?
We have not done anything with that. What would happen in that case would be those questions, all the rest of the questions would get pruned, and so it wouldn't even ask them, and so you'd have a very short questionnaire if somebody sort of, if we let players answer themselves into a corner, as it were.
Yeah. I mean, do you feel that preventing that from happening is something important?
I think if you had,
I think, yeah, if you have enough questions and enough parameters, that's not going to be a problem.
We wrote like not more than a dozen questions, right? Like I don't remember.
Yeah, I think you saw all the questions in our questionnaire, and the intention is that there be large numbers of these, and probably the system be randomly choosing them.
I mean, it sounds like the way the questions are set up that there is some sort of family drama no matter like which course you choose, right? Like
For this particular set, yeah, we were
so
pretty
there's
heavy
not-
on that.
Right.
You can't quite
But we don't.
cancel out.
But to address your question, there's no like explicit like reasoning about like how much is this going to trim down the narrative space. We didn't do any reasoning about that. We just hope that there are enough questions that it doesn't happen. But it is interesting to think about.
Yeah. Yes, sir.
Why should you build a Dread-like interactive fiction game?
Dread's cool. This is more like our particular hobby horse. These are the kinds of games that we like to play. And so providing this experience for ourselves. We just assume there are other nerds like us, and it may be possible that there are not. But the actual experience of playing Dread is fun and unique, and as Liz like very briefly addressed, it's really hard to provide that experience with any of the current like add-ins of AI to gameplay, and so anything that we can do that even comes close to approximating that, we're like, this is interesting. So it's at least for me, it's a very personal.
So it's like bringing the social games to people who don't want to leave their house.
I wouldn't say that, because it isn't, I mean, it's not going to be, assuming we manage to make this thing, it's not going to be a social game. What it's going to be is like a generative anthology where there's a frame story, and then each time you play it, the answering of the questionnaire is going to give you a unique character, and that unique character, by virtue of their uniqueness, is going to get driven through a different path through the possible narratives. And then as you play it enough, if you wanted to, you would be able to sort of disclose more information about the frame narrative.
Like, it's already so fun to like re-roll a character in an ordinary RPG for me, or like in any game that like where the process of character creation is interesting and fun. It's like what is answering this question this way? What are the implications? How is that going to change?
Yeah.
So how is there a particular ordering to the questions at the moment, or are they just presented randomly?
The intention was that they be presented randomly. Actually, right now they're just presented in the order that they are in the file.
So building on some previous comments, it might be interesting to. So as you're asking and answering questions, it's limiting responses and questions that could be asked. It could be interesting to kind of update that ordering such that you're asking the question that will give you like the most information about the player, or maybe trying to like fill out their backstory or the universe as much as you can.
Yeah, the question is how to do that, because stat solving is already NP complete. Now we're sort of getting into sharp P complete, which is like count all the possible models, and that's more scary.
You can cheat by just like picking the one with the fewest hands. Like there are more interesting orders than just deterministic, and that's a good point. Yeah, there are a lot of ways we can cheat this.
On that, it's maybe more a question about the cat stat, but for the local search, did you run any libido challenges?
Digesting the literature on SAT solving and ASP and so on. It's a simple algorithm. It's walk-sat. It's the adaptive novelty plus variant of walk-sat retuned to handle longer clause lengths, because it turns out all of the all the stochastic local search algorithms for SAT are implicitly intended for solving random free-SAT problems. And so you actually have to use different tuning parameters for everything and slightly different strategies.
but then it works. I mean, you're not, like I say, you're not going to use it for like million variable problems, but for simple stuff like this, it seems to work okay. Thank you.
And with that, we have completed day 1 of EXAG. I get to say goodbye to the internet now. I'm going to walk over and say goodbye to the internet. And also, we will see as many of you tomorrow as can make it. So thanks for coming.
Oh, thank you so much.